CloudDB, shaping your new normal.
Okay, welcome everyone to the 2021 APAC Groundbreakers Virtual Tour by Apaco UC. This year, our event will be the biggest one ever done with 144 sessions, including workshops and hands-on labs from 100 different speakers over 17 days. Also, it will cover sessions in 40 different languages. Please remember to register to as many sessions as you can. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and our main sponsor, CloudDB. Now for today's session, Oracle GoldenGate 21c, What's New? By Veeratteshwaran. I don't know if I said that right. Please feel free to write questions at any time during the session using the chat tab of the live webinar, and the speaker will be answering all questions by the end of the session. If you have any technical issues or any problems during the session, please let me know by using the same chat, and I will try to help you the best I can. Now, without any more delays, I would like to leave this amazing session, Oracle GoldenGate 21c, What's New? Vera, can you please share your screen?
Sure, Francisco. So, is it? Yeah.
Yes, it's perfect. We can see is now over there. All right, I will put myself in mute and keep in the background. Have a great presentation.
Sure. Thank you, Francisco. Hello, everyone. Good morning, good afternoon, good evening. My name is Veeratteshwaran Sridhar. In short, everyone used to call me as Veera, and I am working in Fidelity Investments as a principal database administrator. You can see in the screen, you can see the LinkedIn profile and the tweet handle, and I write blogs mostly related to Oracle GoldenGate, and my website is oracle-sen.com, and I continuously support in Oracle forums, right? We have Oracle technology forums wherein many people around the world used to ask questions in the forum, and people used to reply to that. So I used to continuously reply to the queries asked about Oracle GoldenGate in the forums, and my name in the community forum is ORACN, and this is all about me actually. I'm very much passionate about Oracle GoldenGate, and I love to share my knowledge on Oracle GoldenGate. And let's quickly jump into the session. So Oracle GoldenGate, let's start from the basic. So Oracle GoldenGate is a replication tool. Replication in the sense, it's not only the database level replication, right? It's a data level replication wherein you can replicate your data not only from the database to database, but you can also replicate from any database to any non-relational DBMS, right? Non-relational DBMS in the sense like you can replicate your data to Kafka, Cloudera, Spark, Flume, Hadoop, the big data, right? Using Oracle GoldenGate. This is a simple introduction about Oracle GoldenGate, and what you're seeing in the screen is the architecture. We can say it's a traditional or classic architecture. Let me start with explaining about the Oracle GoldenGate architecture, how the data is getting replicated from source to target. So we do have a source and target, and in the source we have a process called extract, and extract, or even we can say it as capture. So extract is a process which is responsible to capture the committed data. That's a key point, right? It captures only the committed data. So captures the committed data from the source database and writes it to a file called trial files, or which will be residing in your the local disk or the file system. So whatever data, the committed data is being captured by the extract process, that will be written to the trial file, the local trials, And there is also another process which is called data pump. Data pump is nothing but it's not the data pump which we do in the database, right? The export and import. This is not that one. This is a different one. The data pump is a process which will be reading the data from the trial file. So whatever data is written by the extract process, that will be read by the data pump process, and the data will be pumped. Only the data, not the entire trial file. Okay, whatever the data is written in the trial file, those data will be read by the data pump, and it will be pumped to the target site over the network. And there is a process called collector in the target site, and the collector process is the one which will receive the data whichever is transferred by the data pump over the network, and it will write the data to the trial files which will be located in the target server, the same target local file system or the target server. And we call that trial files as remote trials. So the server collector process will receive those data, and what it does is it writes the data to the local trials of the target system or the remote system. And from the remote trial, the replicate or the apply process. So that is a process which will be reading whatever changes has been written by the collector process, right? Whatever data has been written by the collector process in the remote trial file, those data will be read by the replicate process, and the data will be converted into SQL statements. So the trial files, we cannot just simply open the trial file and see the data. So that will be written in its own canonical format by the Oracle GoldenGate process itself. So we cannot go and read the trial file just by using the VI editor or right click and open the file. That's not possible. So that is written in its own canonical format, and whatever data is written, right, the replicate is to read the data and it constructs the data as an SQL statement, and then the data is applied to the target site. So this is how the classic architecture works. We could see the manager process on both the sides, source and target, and manager is a process which will be managing all the other processes of the Oracle GoldenGate. It manages the extract, data pump, collector, replicate. So that is a process which will be managing all the sub processes of Oracle GoldenGate, and without that process, you cannot start any other process. Even if you want to start the extract process or start the data pump process, you need the manager to be up and running. So the manager is responsible for each and everything happening in the Oracle GoldenGate. So this is all about the classic architecture. And current, there is also an architecture called microservices, which I will be explaining in the next slide. But in the left hand side, you can see the components of classic architecture. We have a manager process, the extract or capture process, the data pump process. Otherwise, we can even call it as a secondary extract process. It is also a kind of an extract process. Server collector process, that is nothing but the collector process. And we have the replicate or apply process, trial files. And to operate all these processes, right, we do have a CLI, the GoldenGate software command interface, which is nothing but the GGSCI. It's a command line interface wherein we execute all the commands, and we can execute all the commands like start, stop. There are so many number of commands we can interact using this, and we can handle the Oracle GoldenGate processes. And if you see in the right hand side, we have microservices architecture. In the microservices architecture, we do have the same extract or capture process, and we do have the same replicate and apply process. And yes, we have the trial files. But what is differing when comparing to the classic architecture is we have a service manager. So in the classic architecture, we have manager process, wherein in the microservices, we have service manager. And we have additionally administration server, which is nothing but in the classic architecture, as I mentioned right in the previous slide, manager process is the one which will be managing all the sub processes of Oracle GoldenGate. Likewise, in the microservices architecture, administration server is the one which will be managing all the sub processes of Oracle GoldenGate, wherein the service manager is just a service, just a manager, which is like a watchdog, whether all my processes are up and running. It will just watch the other processes, but it doesn't have any control on it. So the entire control is on the administration server. We have a distribution server, like we have a data pump process in the classic architecture. We have distribution server in the microservices architecture. We have server collector in the classic architecture that is replaced by receiver server in the microservices architecture. And we have additionally performance metric server, which is to monitor your performance of the Oracle GoldenGate processes. And like we have GGSCI, the command line interface in classic architecture. here it is a bit different. We have admin client, that is the one which acts as a command line interface, wherein we can interact with the Oracle GoldenGate processes. And this microservices architecture is completely a GUI based, so completely a graphical user interface. Where in classic architecture we don't have that option. We have only the command line CLI mode of interaction, right? Wherein in microservices we have both the options. One is the graphical user interface as well as the command line interface. This is the architecture of microservices. So, like I said, we have admin server on both the side. We have service manager on both the side. On the source side, you can see the distribution server, the extract server. The extract server will be capturing the committed data from the database, writing to the local trial, and here it is the distribution server. In the classic, it is data pump, but in the microservices, it is the distribution server. Right? That distribution server will be reading the data, and it will be pushing the data to the target via the network, the TCP network. And instead of connector, we have the receiver server. Receiver server is the one which will be reading all those data, receiving all those data and writing those data to the remote trial files. And from the remote trial file, the replicate is a process which will be reading the data from the remote trial file, and it will apply the data to the target database. So additionally, like I explained, we have a service manager, which is just a watchdog, and we have admin server, which completely handles all the manages all the sub processes of Oracle GoldenGate. And instead of the GGSCI prompt, we have the admin client in here. And the major thing is it all works on the RESTful API, the entire microservices architecture. That is one of the biggest difference over here. It all works on the network, HTTPS network. So hope now we are clear about the classic architecture and microservices architecture of Oracle GoldenGate. And Oracle GoldenGate is very flexible in nature. We have different types of topologies available in Oracle GoldenGate, and we can architect the replication solution as per our needs. So that flexibility is. So we have one-to-one, one source and one target, wherein we replicate the data from one source to one target. We have bidirectional. We have site A and site B, and we can replicate the data vice versa from A to B and B to A. Even that is possible. We have one-to-many whenever we want to broadcast our data from a centralized server to other client servers. Yeah, we can do it from one single server. We can capture the data and replicate to multiple targets. Many to one. For example, let's take an example of the reporting server. Right, we consolidate. We have multiple sources. We consolidate all the data into a single target server and generate the report. So even that is possible. We call it as many to one. The next topology is cascading. Cascading is nothing but so like we have a cascaded standby in Oracle database, right? So when we have one primary and multiple standby database, we don't want to put much pressure on the primary database to replicate the data to all the standby databases. So what we do is we replicate the data to one single standby, and from there, again, we replicate to the other standby database. Likewise, we have cascading topology here, like we can replicate to one target, and from that target, we can configure the GoldenGate extract data pump and replicate, and we can replicate to multiple targets. And peer-to-peer is nothing but if I have three sites, A, B, C, all the data will be replicating to all the sites, like A to B, B to A, B to C, C to B, and A to C, C to A. Like that. That is called peer-to-peer topology. So today we are going to see Oracle GoldenGate 21c. What's new? So there are a lot of enhancement and major features available in 21c. And which makes our life much easier. Let's see all about it one by one. There are n number of features available in 21c, but today, due to the time limitation, right, I'm going to explain only few of the features, which are, but those features are very major ones. So let's get into this. So firstly, let's talk about microservices architecture. The microservices architecture initially got introduced from the version 12.3, and that was mainly introduced only for the Oracle database. So Oracle GoldenGate is an heterogeneous replication tool wherein you can replicate data from any database to any database. But since this was the introduction of the new architecture, right, the working methodology itself is completely different when comparing to the classic architecture. So Oracle introduced this microservices architecture initially only for the Oracle database, But today, right, from Oracle GoldenGate 21c, they slowly increased the support of the servers, database servers, like the microservices architecture is also available for not only for Oracle but also like DB2 ZOS, MySQL, SQL Server, and Postgres Server. And the microservices architecture is also available for the big data adapters, right? Big data adapters are mainly used to replicate your data to non-relational database management systems. That is nothing but the Kafka, Cassandra, etc., right? Hadoop big data. So that is wherein we will be using the big data adapters. Even for big data adapters, now the microservices architecture is available. This is one of the enhancement we could say from Oracle GoldenGate 21c. And if you go to this, the download section of Oracle GoldenGate, you can see the microservices architecture binaries are available for each and every databases. For example, it is available for Oracle. You can see the keyword microservices. Actually, when you go to this download site, the Oracle download site, you can see both the binaries available. One is for the classic architecture. The other one is for the microservices architecture. For the classic architecture, you will not see the keyword microservices. So if it is without the keyword microservices, then it is for the classic architecture. The binaries are for the classic. And when explicitly microservices are mentioned, which you are seeing in the screen, that is for the microservices architecture. So, for example, if you see the big data in the bottom right, Oracle GoldenGate for big data 21.3.0.0, you can see two binaries over there. One is for the classic, wherein you don't have the keyword microservices, and the bottom one is for the microservices. So both the architecture, the binaries for both the architectures are available. So based on your requirement, you can go ahead and download any of the one, and you can start utilizing it. The second one is OGG 21c unified build. This is also one of the major feature, I could say. So let's take an example. Excuse me. I have a source and target, wherein in the source I have Oracle database 12c with Oracle GoldenGate 19c, and in the target I have Oracle database 19c with Oracle GoldenGate 19c. And I have GoldenGate installed on the database server itself, right? So I installed my GoldenGate where exactly the database is also running. So it is in the same server. So this obviously will work. But what about the scenario which we are seeing now? So the same source and target, wherein I have 12c database in the source and 19c database in the target, but I have installed Oracle GoldenGate 19c in a separate server, which we call it as hub. This is again a different topology, one of the topologies available for Oracle GoldenGate. It's not necessary that you need to install your Oracle GoldenGate on the same server. We can also use it as a hub kind of model. That is where the entire GoldenGate world is moving to. So everyone are moving to the hub and spoke model. And here we have installed Oracle GoldenGate 19c on the hub server. But what do you think about it? Will this work? If I have a source and target in a different server and having a GoldenGate on a hub server, on a different server, which will be acting as a centralized hub for both source and target, will this work? So obviously no, right? Why? Because we have some more prerequisites to make this model work. So we need to have a client to be installed on the hub server, because Oracle GoldenGate refers the Oracle libraries to make the replication work. So in the previous model, right, the GoldenGate is installed in the server where the database is installed. So we do have the profile set in the OS level. Like for example, for any shell, right, for KSH or CSH bash, we have profile set wherein we will be mentioning all the parameters like Oracle home, class path, LD library path, right? The LD library path is the main thing actually works in here. So the GoldenGate refers the Oracle libraries, which is available in the Oracle database itself. But in this scenario, since it is installed in a separate hub, right, in a separate server, it needs the client. It needs the Oracle libraries for reference, so that the replication works fine, or else the GoldenGate replication will not work fine. So that is one of the prerequisites. And then next thing is, we have different versions of Oracle GoldenGate, Oracle database. On the source it is 12c, on the target it is 19c. So what we need to do is, whenever you install Oracle GoldenGate 19c, hope you all might have seen right in the installation screen, you will have multiple options for which database you want to install the Oracle GoldenGate, right? So that is one of the options, or the one of the part of the installation. So I need to install, or we need to install Oracle GoldenGate twice in the centralized hub server, in the GoldenGate hub server. One GoldenGate binary for Oracle database 12c, and the other GoldenGate binary for Oracle database 19c. So let's see, take an example of an hybrid environment wherein I have multiple flavors of versions of database. For example, I have database 19c, 18c, and 12c all together, and what can be done in here? Definitely, I need to install Oracle client for the reference, and I need to make 3 installations, right? One is for the 12c database, one is for the 18c database, and one is for the 19c database. So if I have 11g database as well here, then again it will become 4 installations, right? I need to install Oracle GoldenGate for 11g database. So this is one of the it was additional burden for the replication experts of the DBAs in concern, right? So whenever they make an upgrade, it will be difficult for them to do it with a lot of installations of GoldenGate. Even though we make it as GoldenGate as a centralized hub server, still we need to have multiple installations of GoldenGate for different versions of database. So this is how it looks like in the previous versions, right? Prior to 21c, we have options here. So we need to select the option of the database versions in order to install the Oracle GoldenGate. But from 21c, what happens is that option is completely eliminated. So we do have this screen actually. We do have this installation screen, like it will ask for select the database for this Oracle GoldenGate installation. But if you see, there are no different kinds of database versions available, right? So it has only one point where which is nothing but Oracle GoldenGate for Oracle database 21c and lower supported versions. So this version of GoldenGate is supported for 21c and the lower versions of 21c database, right? So this is one of the major enhancement. So we can say, like, what exactly is the benefit of removing the options, right? I'll explain in the future slide about that. And you can also see prior to GoldenGate 21c, right, in the first screen, the first image in the screen, you can see the library is available. And when we compare with the OGG 21c, right, the Oracle client, instant client, is bundled with the Oracle GoldenGate binaries itself. So this is one of the, again, it's a 2-in-1 actually. Unified build is a 2-in-1 feature, we can say. So one is we don't have the options of selecting the database versions. And the second one is the instant client. Oracle instant client is bundled with the Oracle GoldenGate binaries, Oracle GoldenGate 21c binaries. So how this helps, even in the client, the previous images was from the Oracle GoldenGate Microservices architecture. And just to confirm it, I just had one more image. It is from the classic architecture. And you can see the instant client, right? This is what I made the list of the files, libraries from the instant client directory. And the instant client is bundled with the Oracle GoldenGate 21c binaries itself. So, for example, the same thing, like a hybrid environment, right? I have a different versions of Oracle database, and I have a centralized hub of Oracle GoldenGate with Oracle GoldenGate version 21c. So I don't want client to be installed over there. One of the prerequisites for the centralized hub is being removed. And second one is only one installation of GoldenGate is enough. Even though if I had multiple versions of database, only one installation of GoldenGate is enough, right? And my maintenance is completely reduced over here. So even though if I have 12c database, 18c database, and 19c database, so I can just make only one installation of GoldenGate, which will take care of all the database versions. So there is no dependency of the database versions for the GoldenGate from Oracle GoldenGate 21c. And the major benefit of this, what I believe is, suppose I have a version Oracle database 12c, and I have Oracle GoldenGate 19c for 12c database. Obviously, this is my first version. So I need to select for which version I'm going to install, and I have Oracle OGG 19c for 12c DB. So suppose if I'm going to upgrade my database to 18c, so what happens? I need to reinstall my GoldenGate, right? Because Oracle GoldenGate for 12c will never support Oracle database 18c. So I need to reinstall my GoldenGate based on the version of database. Again, if I am going to upgrade my database to 19c, again I need to reinstall my Oracle GoldenGate for the respective database version. So for each and every upgrade, I need to reinstall my GoldenGate. But this is prior to 21c. But from Oracle GoldenGate 21c, what is going to happen is I have a database. The same database is going to upgrade. It's not 3 different databases. But I have Oracle GoldenGate 21c installed. So what will happen? Even though if I upgrade my database from 12c to 18c or from 18c to 19c, I don't want to reinstall the GoldenGate at all, right? So because it supports all the versions of the GoldenGate, all the versions of the database. Even though if I upgrade my 19c database to 21c, I don't want to again reinstall my GoldenGate. So this is one of the major benefit from the unified build, and it really eases our work whenever we do an upgrade of the database. The third feature is DB unique name in trial file header. So what is trial file header? For whenever you open a trial file, as I told you, we cannot open using an VI editor or just right click and do a open. That's not possible. We have a separate utility called logdump. And if you want to know more about the logdump utility, this is the link here. You can I have written an article on the Oracle GoldenGate logdump utility. You can just go there and you can have more details about it. And using this logdump, whenever you open a trial file, the first thing whichever is going to come is the trial file header information. And that trial file header information, we have certain commands. We need to enable that. We need to execute that command in order to enable the trial file header. To view the trial file header in the trial file. So file header off is the one when you give file header off, you cannot view the file header of the trial file. And file header on displays only the main header tokens, and file header detail is the one which will display the main header tokens along with its sub tokens. So these are the three commands available. You can execute it in the logdump, and you can see the details in the trial file header information. And these are the main header tokens: trial file info, mission info, database info, producer info, and continuity info. And from 21c, right, DB unique name is added to the database info. But what is the benefit of it? We can say, like, whenever we have a bi-directional replication, right, for the source and target, database name might be the same, but how do we differentiate it? So that makes us confused, right? So what we can do is, since the DB unique name is added to the database info of the trial file, and that we can just simply open the trial file using the logdump utility, and we can make a trial file header on with detail, right? That is a command. So once you give that command, so you will get the detailed information of the trial file header, and you can see whether what database is it is source database or target database, right? So this really helps in the troubleshooting scenarios whenever we have replication issues in a bi-directional replication. So in order to find which database the issue is, either it is in the source or the target, if the database names are same. So that is one of the minor enhancement available in Oracle GoldenGate 21c. And in the left-hand side, you can see Oracle GoldenGate 19c. And this is how the database info looks like in the trial file header. But in the right-hand side, I just highlighted in the like a square thing. So that is a DB unique name which is added to the trial file header. And this header information, right, we can even fetch it as a token, and we can store it in a table in the target side. Even that is possible. So from that thing, we can come to know, like, from where exactly the data is coming, right? From which, if we add the database unique name as a token in one of the table, for example, if we are maintaining the history of the transactions, we can add additional columns, which can be those additional columns, right? The details can be fetched from the header of the trial file. So with that, if we add this DB unique name each and time whenever a record is getting inserted, even the DB unique name will be added over there, so we can easily identify which is the target or which is the source. Parallel replicate enhancement. Just watching. Okay. Parallel replicate enhancement. The next major thing in Oracle GoldenGate 21c. Let's see how the history of the processes in Oracle GoldenGate. So prior to 11G R2, right? 11.2.x. So extract, there were only two processes, extract and replicate. Of course, data pump was there, but data pump process is just a process which will be pushing the data, right? It doesn't do much of the thing, just to push the data from source to target. That is one of the major role of the data pump, but it's not going to extract the data or apply the data to the source or target or something like that. So we are just going to talk only about the extract and replicate. So we have only the extract and replicate process in prior to 11G R2 version, and from 11.2, this was completely renamed as classic extract and classic replicate. So when Oracle bought this GoldenGate, there are only two processes, extract and replicate. And from 11.2, what Oracle did is like they introduced a new kind of capture or extract process, which is nothing but integrated extract. So in order to differentiate both the extract processes, they made that as a classic extract, and this is an integrated extract. And from 12C R1, we have classic extract and the integrated extract, and we have classic replicate, and they introduced integrated replicate as well as coordinated replicate. So this integrated extract and integrated replicate are mainly for Oracle database. It doesn't work for any other databases like SQL Server or MySQL or the DB2. So it is mainly introduced to increase the performance of the capture and apply rate. Most probably 99% we will never see much performance issues on the extract side. Majorly we will see all the performance issue only on the target side, the replicate side. So the classic extract is more than enough to capture a huge amount of data. And since for the apply side, right, for the target side, we have integrated replicate for the database, Oracle database, but we don't have any other apply process for the other databases apart from Oracle. So what they did is they introduced coordinated replicate. So these all works on the parallelism, which increases the throughput of the replicate process, the apply rate of the replicate process. And from 12.3, we have classic extract, integrated extract, classic replicate, integrated replicate, coordinated replicate, and Oracle introduced parallel replicate. And this parallel replicate is 5 times faster than the integrated replicate. Integrated replicate itself is much faster, but parallel replicate is much more faster than the integrated replicate. And the major advantage of parallel replicate is, of course, integrated replicate do have parallelism, and even the parallel replicate from the name itself, of course, it also has the parallelism. But whenever there is a huge transaction, right, single large transaction, you see, provides the option to apply a single large transaction in parallel. So this option is not available in the integrated replicate. Suppose if I have a parallelism of 5 in integrated replicate, and there is a large single large transaction coming from the source to target, out of these 5 parallel processes, whichever process goes and read that single large transaction, only that single process will keep on processing the entire transaction, right? So the other 4 processes, if they don't have any other data coming in from the source to the target, all the 4 parallel processes will be idle. So even though I have parallelism, I'm losing it, right? Of course, the 4 parallel processes are idle, but only one single parallel process will be working. But in parallel replicate, one single large transaction will be split into multiple chunks, right? We have split tran_rex, that's a parameter. By default, it is 1 lakh, and you can mention it like you can have a value of 500 or 1000 or something. Suppose if I have 2 million records, DML operations in one single large transaction, the 2 million operations will be split into, for example, I have 1000 as a split tran_rex. So the 2 million operations will be split into 1000 chunks, and it will be applied in parallel. So that makes the parallel replicate much faster when comparing to the integrated replicate. This is architecture of parallel replicate. From the trial file, we have mapper, collator, scheduler, and applier, and these are the background processes. Like we have in integrated process, we have builder, preparer, applier, right? Similarly, we have background processes for parallel replicate. These are all works internally, and it maintains even the dependencies of between the transactions. Even though multiple parallel process are spawned and applied in parallel, the dependency of the transactions are maintained internally, and this is the simple architecture of the parallel replicate. And this parallel replicate was mainly introduced. I mean, this is only kind of what is it? It is of 2 types actually. You can see the last column, right? We have ni bar I. It means like we have 2 types of parallel replicate. One is integrated parallel replicate, and the second one is non-integrated parallel replicate. Okay. The only difference is, if you see the previous screen, the only difference between the integrated parallel replicate and non-integrated parallel replicate is, in the integrated parallel replicate, the applier processes, right? We have the master node, and we have different sub processes: mapper, collator, scheduler, and applier. In the integrated parallel replicate, the applier process runs inside the database. Okay, but in the non-integrated parallel replicate, the complete process itself is out of the box. So there is no link between the database or the apply process, the parallel replicate process. So it is completely out of the box. There is no dependency between the database and the replicate process. But for the integrated parallel replicate process, the applier process runs in the database. So the integrated parallel replicate process is available only for the Oracle database. Okay, and these are the comparisons with the existing replicates. The batch processing. See, for classic, the only for classic replicate only one. The first one is available. Other all it's not available. And slowly it has been enhanced based on the different types of replicate process. And if you see, we do have restrictions for the non-integrated replicate process, like auto CDR is not supported, procedural replication is not supported, and the DML handler is not supported. But for the integrated parallel replicate, all the options or all the features are supported. And for parallel, as I told you, right, parallel integrated replicate is mainly for Oracle database, but even non-integrated parallel replicate also can be used for the Oracle database. But from 21c, what happened is they enhanced the parallel replicate, I mean the non-integrated parallel replicate for other heterogeneous databases as well. So the non-integrated parallel replicate, earlier it was only for Oracle database, but now we can use it for SQL Server, MySQL, DB to ZOS, and for even for the big data adapters. I believe I read it somewhere in the documentation. So I'm just doing a small research on it and writing an article. Sooner I will be publishing it in my blog. So even for big data adapters, for Kafka, Hadoop, Cloudera, Apache, Spark, even for the big data adapters, the non-integrated parallel replicate can be used, but parallel integrated replicate can be used only for the Oracle database. And one next major feature is auto capture. Prior to Oracle GoldenGate 21c, for example, like if we need to add a table to the extract parameter file, right? Suppose if I want to capture the data of a particular table, so what I do is I simply give the statement table is a parameter for the extract parameter file, table space the schema name and the table name, right? The table name of the for which I need to capture the data. And if it is a CDB or the multi-tenant environment, what we do is we use the source catalog, right, and give the PDB name. Since we have multiple PDBs over there, we used to give source catalog, the PDB name, and inside the PDB, obviously the table parameter. So inside the PDB, from which schema and what is the table name, we used to specify. And this is for a single table. Suppose if you want to capture the entire schema itself, what we used to do is table and schema.start. That is a wildcard we use. So whatever tables are there in that particular schema, all the tables data will be captured by the extract or capture process. And the same thing for the CDB. The only thing is we use the additional parameter source catalog and the PDB name, and the table parameter is same. We need to use table space schema name dot star is the wildcard. Okay. And if you want to remove a table from the table level replication, the first one is the table level replication, and the second one is schema level replication. Suppose if you want to remove a table out of the replication from the table level replication, we simply go and edit the extract parameter file and just comment out, right? Double hyphen is the comment for in the GoldenGate editor, right? So just give double hyphen and that particular table parameter will be commented out, and once you restart the process, obviously for that particular table the data will not be captured. And if it is a schema level replication, we can use the parameter table exclude in the source, or in the the source extract on the replicate parameter file, you can use the map exclude. So we can give the table name so that particular table's record will not be captured by the extract process. So from Oracle GoldenGate 21c, a major enhancement or one of the major feature, I can say, it's not an enhancement, it's a feature. We can say auto capture mode. Okay. So for auto capture mode, there is an additional parameter introduced, which is nothing but translog options enable auto capture. That is a parameter which needs to be given in the extract process parameter file. And then obviously there is a prerequisite for Oracle GoldenGate replication itself. At the database level, definitely we need to enable a minimum supplemental log. And at the GGSE, right, at the GoldenGate level, we need to add the tran data for the table. So if this parameter translog options enable auto capture is there in the extract process parameter file, and if I have supplemental logging and tran data enabled for a particular table, you don't want to mention the table parameter at all. So once you start the extract process, automatically the extract will capture the data of that particular table. Okay, so if you want to enable the same thing for a schema, so obviously the supplemental logging will be added in the database level, and schema tran data for the particular schema will be added at the GGSEA, at the GoldenGate level. So once you start the extract, whatever data is been there for the tables in that particular schema, all the table data will be captured by the extract process. And additionally, there is a column in the database view, DB underscore tables or CDB underscore tables, right? We have additional column called logical replication. So by default, this logical replication is enabled. So let's see in detail. So these are the prerequisites for Oracle GoldenGate 21c auto capture mode. The database version should be 21c or higher, and you need to have a supplemental logging enabled either at the table level or schema level, and the tran data should be enabled for all the columns. Why? Because we may have primary key in some tables, and we may not have primary key, right? So for that, for the auto capture to work, we need to log all the keys of the table, all the columns of the table. So for that, we need to use the all keys option whenever you add the tran data for the table or the schema. These are the prerequisites for the auto capture. And how the auto capture works is, suppose in the database I have an employee table and I have an extract process, and I have added the supplemental log and as well as the tran data, and I have the parameter tran log options enable auto capture in the extract process parameter file. So when I start my extract process parameter file, automatically whatever changes happening to that particular table will be captured by the extract process, and it will be written to the trial file. So this is a simple workflow how the auto capture works. And let's see a small demo. So I'm just creating a table, source.employee. Source is a schema and employee is a table, and table is created, and just describing the table. I have only 3 columns: employee ID, employee name, and department, and employee ID is the primary key. So now, as I told you, there is additional column, right? Logical replication, which has been added to the DB underscore tables or the CDB underscore tables. And if you see, as soon as I created the table and I query this database view, and I can see the logical replication as enabled. So by default, this logical replication is enabled. So let's see in the GGSEA side, I'm just giving info tran data for that particular table employee, and you can see the tran data is disabled currently. Okay, but the supplemental log is I just enabled at the database level. Minimum supplemental logging is enabled. If it is not enabled, even the add tran data will take care of it completely. So when you give add tran data, all calls, right? I told you, like for the auto capture, one of the prerequisites is we need to use the all keys for the supplemental log. All keys is option, but for the tran data, it is all calls. So when I just added the tran data for the particular table with all calls option, and you can see the tran data as well as the supplemental logging, everything is enabled. Now I just viewed my parameter. eMicro is my extract process, and you can see I don't have the table parameter or any source. What is that? Even the PDB, right? Source catalog. I don't have anything. I just my last parameter in the parameter file is ext trial et. So this is an MA architecture, and you can see the parameter tran log options enable auto capture is there in the parameter file. Okay, but there is no table parameter. So let me insert a record now. Insert into source. Source, and I just committed the record, and if you see, if I do a select start from table, obviously you can see the record, and I have supplemental log added, tran data is enabled, logical replication enabled by default, and I have the below parameters. See, all the prerequisites are satisfied now. So let's see how if this insert is being captured by the extract process or not. Starts extract eMicro table, and this is the command to see if the insert or any DML operations of the particular table, the statistics of the extract process, and you can see there is one insert record which has been captured by the extract process. Right. So now what I'm going to do is I'm going to remove the table from the replication. Right. In the normal way, what we do is we used to comment the table parameter, or we used to use the table exclude. But here I'm going to disable the logical replication. So when I query it, I made the logical replication which was enabled, I made it as disabled. So now let's see how it works. Okay. I'm doing an info tran data. Even though my logical replication is disabled, still my tran data and supplemental log is not removed. It is still in enabled state. Okay. So now let's insert a data again, inserting one more record to the table and committing it. And when I do a select query, and I can see 2 records, and this is the new record which has got inserted by us. And here one prerequisite is disabled. Supplemental log, tran data, and the parameter is all present, but logical replication is disabled. Let's see whether the insert is being captured by the extract process or not. When the stats command is the one which will be helpful. And if you see again, I have only one insert, right? Actually, there should be 2 inserts here. So if the new insert is getting captured or being captured by the extract process, because we need to see 2 inserts, but still it is only 1 insert. This means the record is not being captured. Obviously, the table got removed from the replication. To enable back the replication, it's a simple SQL statement under table name, enable logical replication. But will this enable back the replication? No. So I just did a research. I was doing a lot of practical things here, and I just triggered this statement, but still I couldn't see the data in the new data, which after this statement, whatever new data I inserted, I couldn't see in the GoldenGate. So what is the thing is, the tricky part in here is, yes, first we need to enable the logical replication, and then we need to delete and re-add the tran data. So that is one of the major point in here. Simply enabling back the logical replication will never work. It will not put back the table into the replication. We need to delete the tran data and re-add the tran data for that particular table or for the schema. Suppose if you are going to remove the complete schema out of the replication, right? So we need to do this in order to bring back the table or schema to the replication. And auto CDR. So auto CDR is one. Suppose we have 2 sites wherein application is connected on both the sites, and I'm doing update on both the sites. What happens is, like, we need something to resolve, right? It's nothing but timestamp, and these are the different types of basic conflicts handled by CDR. CDR is nothing but conflict detection and resolution, and for insert, update, and delete, we have various errors, which will be these are the conflicts which will be handled by the CDR. CDR is a manual process wherein we need to tell the replicate process how to resolve the conflicts, right? So we need to say, like, if there is an insert already, the record is there present in the target side, and the same record is coming from the source, what needs to be done? Whether it should overwrite, or it should ignore, or it should discard, or based on the maximum timestamp and minimum timestamp, what needs to be done? These are the conflict resolution based on timestamp. So obviously, for any CDR concepts, we use only the timestamp. And these are the different types of conflicts and different types of how we resolve it. So we need to give manually all the things, but from 4.3, right, auto CDR was introduced, and it is a built-in CDR, so we don't want to mention all these things. By default, it works on the maximum timestamp available, and that is how the concept works for the auto CDR. And by default, you don't want to enable any, you don't want to add any timestamp column to the tables. An invisible timestamp column will be automatically added by the CDR itself, the auto CDR itself, and it will be maintained automatically. And the major drawback is the latest record always wins here. The record which has the highest timestamp will win always in the auto CDR. So these are the requirements. The Oracle database would be 12.2, and we need integrated extract and primary key is mandatory. And a simple configuration, add parameter map invisible columns in the replicate process parameter file. And once you connect to the database, we need to invoke a package or execute this DBMS package and give the schema name and table name, so that the auto CDR for that particular table will be enabled automatically. So what happens when auto CDR works? It creates automatically an invisible timestamp column, right? That is what happens when I create an employee table. Automatically, an invisible column will be created, and this column is automatically maintained. And also, a tombstone table will be created for the particular table. So how many ever table you create or add to the auto CDR, so that many tables will be created as the tombstone table will be created for the respective tables which are added to the auto CDR. And when an insert is done, this is how it happens. You can see the timestamp P1. Automatically, the timestamp column will be there. And for the update, this is what happens. The timestamp, the latest timestamp will be automatically updated in the invisible timestamp column. And for the delete, the record will be deleted, but the record information will be there in the employee table for the later conflict purpose. If the record is needed, it will fetch the data from the tombstone table, and it will do a conflict, and it will resolve it. That is the reason why we have the tombstone table. It's a very big concept, the auto CDR. These are the various types of conflicts we have. And CDR versus auto CDR. CDR supports only 4 types of conflicts, wherein auto CDR, it has additional 4 types of conflicts supported: insert, update, insert, delete, column, group, and piecewise log. And this is how the parameter looks like. CDR replicate parameter file. If you see in the left hand side, it's a huge parameter file, right? But if you see in the right hand side, we have only one line. So we don't want to mention each and every conflict, how it needs to be handled by the replicate process. And that is a difference. CDR manually configure the parameters for CDR. It is one command. And the major thing is we have full control on the CDR, wherein in auto CDR, right, we don't have control at all, because it automatically works on the use max of timestamp. The maximum timestamp or the highest timestamp always wins. So yes, of course, we don't have no control, and it's a major drawback. So that is what I mentioned. It uses the max timestamp of for all the conflicts. For airline ticket reservation, we have 2 guys. One guy is booking the ticket from phone, and one guy is booking the ticket from system. And the guy who books from the phone has booked the ticket at 9:30 a.m. But the guy who booked from the system, right, just one second delay, 9:30:01 a.m. right. But who needs to get the ticket actually? It should be the guy who booked from the phone, right? But here, since in the auto CDR, the latest timestamp wins, what happens is the guy who booked from the system, right, he will get the ticket allotted. So that's not the correct one, right? But the actual one is the guy who booked from the phone should get the ticket. So in all the environments, we cannot use the auto CDR option. So this is the example, classic example, the airline ticket reservation. And from 21c, this was a little bit enhanced. So the earliest timestamp has been added, and even the site priority based resolution is also added. So prior to 21c, it was only the use max of timestamp. Now it is use min of timestamp is also available in auto CDR, and even from which site priority. I need to resolve only, I need to always, or the site A should always win when comparing to site B, right? Even that is also possible. And from 21c, latest timestamp based resolution, earliest timestamp based resolution, and site priority based resolution is available for auto CDR. Per DB capture, earlier we need to connect to the CDB database in order to capture the data using the extract process, and we'll be creating the C hash as GG admin, which is nothing but the common user. And for the autonomous database, this won't be possible, because in a shared autonomous, I may own one PDB and you may own one PDB, so we cannot give the access to the CDB root container, right? So that is an enhancement for the autonomous database. The extract process is capable of directly connecting to the PDB, and it will capture the data. So this is one of the another enhancement from Oracle GoldenGate 21c. So we do have other features. There are a number of features, as I mentioned. You can go through the docs.oracle.com, like DB unique name with the heartbeat table. The upgrade has been made very simplified. Actually, only fewer steps are there. And bounded recovery performance has been enhanced. New replicate parameter include tag has been added to the from Oracle GoldenGate 21c. And the link is below. You can just go to this link and you can see other features of Oracle GoldenGate, not only for the core but also for the big data. I like the first feature very much, Kafka capture. Earlier it was from Cassandra. Now Oracle GoldenGate Big Data Adapter has the ability to capture the data from Kafka itself. And the last stuff is like we all spoke about. We all saw about how what are the enhancements. But there are also few features which got deprecated and desupported. Classic extract is completely desupported for the Oracle database, but for the other databases it is still available. And the classic architecture is deprecated, and sooner in the future releases, the classic architecture itself may be removed or desupported from GoldenGate. So Oracle recommends us to move to microservices architecture. And RMT task, right? Whenever you do a initial load, we use RMT task, which will automatically trigger or start the replicate process, initial load replicate process in the target side. That's got deprecated and desupported. And Oracle sharding that got deprecated. And from Oracle database 21c, the sharding has limitations of using only one pluggable database in the container database. So these are the few deprecated or desupported features and parameters from Oracle GoldenGate 21c. So these are a few articles which I have written in my blog. You can go through this links and you can have the detailed information of whatever I have explained now, the Oracle GoldenGate 21c new features. And thank you. And if you have any questions, yeah, we can go ahead.
Okay, Vera. Looks like hi Vera. Looks like it is no questions for the moment. They only had questions about the recording that will be available within all the user groups participating, and also in the YouTube channel of Apaco UC called OracleMania a few weeks after the end of the event. If you guys have any questions, please feel free to contact Vera via Twitter or his email, all the contact information he shares on his presentation, or you can let us know here in the event, and we will then transfer any questions directly to the speaker, in this case, Vera. And saying that, thank you so much, everyone. Please hope you continue enjoying the next 17 days of sessions and register to the most you can. And be safe and look after yourself and your family. Thank you, Vera. It was an excellent presentation.
Thank you, Francisco and APAC Oracle User Group for providing me this opportunity to present in a huge conference, one of the biggest event in Asia Pacific. Right. Thank you very much for the opportunity. Thank you.
Thank you so much. Have a wonderful afternoon and night, depending on where everyone is around the world.
CloudDB, shaping your new normal.